Okay, hi. So I'm going to explain this question. So this was the question I got. What we know is the bar or the beam is uniform. It's 7.5 meters long, 1,200 kilograms. The cable is attached 2 meters from the end, and then the 30 degrees down here. So that's the free body diagram or not free body diagram, sorry. Just the sketch we got. I did draw a free body diagram over here and then just some other sketches to help me. So first off, I'll just start by saying that since the system is at equilibrium, we know that all three of these will be equal to 0. So part A asks us to find the tension. I chose to use this one. The reason I chose to use that one was because we did not know the reaction forces yet, and those are actually equal to 0 because the rotation is at this end of the beam. Those would just be equal to 0, so we can just leave those out of this equation and find tension. So so the R and then the tension perpendicular minus R and FG perpendicular, that's equal to 0. So the 5.5 and the 3.75 here I found using this. So we know that the 7.5 here minus the 2 is equal to 5.5 meters. And then the force of gravity is at the center of gravity, or center of mass. So that's in the middle. So we know that 7.5 divided by 2 is 3.75. And then the t cos 50 is t perpendicular. I found that up here. Which one? This one. So the t perpendicular, we know that this is 40 degrees. So that's a total of 90 degrees here. And then that makes that 50. So t cos 50 is equal to the tension perpendicular. And then force of gravity perpendicular would be here. So we know that 180 degrees in a triangle, so that makes that 60. This is 90 degrees, so that's 30. So FG cos 30 is equal to 0. And then just solve for t. So solving for t, I got this as my final answer. And then in the correct sig figs, that's this here. Oh, I left this here. My bad. So that's the final answer for that, 11,000 newtons. Part B, we had to find the reaction force, so that's Rx and Ry. I chose to use this one, and then this one. So we know that Ry plus Ty minus Fg. So Ry is up, Ty is up, and Fg is down. So that's equal to 0. So Ry is equal to mg t sine 10. The 10 degrees is here. So this was originally given to us 30 degrees here, which makes that 30 degrees. We knew that that was 40 degrees, so that makes that 10. So yeah, that's how we found the 10 degrees. So t sine 10 is the y direction. So then we solved and we got 9,900 newtons. And then F, or net force in the x direction, is equal to the Rx here. Fg is equal to 0 in the x direction since it's straight down. And then the t is right here. So that's Tx is equal to t cos 10. So solve for that Rx here. We get this. It rounds to the same number as this last one did, even though it's slightly different, but it's really close. So when you put in the correct sig figs, it could be a little confusing. But yeah, that's the end of part B. And here's part A, just the full page in case you needed that. So thanks. Sorry if I was super awkward. This is kind of weird.